Welcome to today's session. Namhlanje we are going to be talking about electric circuits. Our main focus will be based on EMF as well as terminal potential difference. So, what comes into your mind when we say electric circuit or a circuit? What is the first thing that you think about as a student? I am anticipating that things that you thought about include a battery, which is going to be the source of energy, a load, which will use the energy that is sourced by the battery, conductor that is going to allow flow of charges across your circuit. And I hope you do not forget the switch, which controls the flow of current in a circuit. Of course, we continue. So, this is a sketch of what a circuit possibly should look like. We have our device, which we can consider it as our bulb device. We have our cells that make up a battery, as well as our switch, the one that controls the flow of charges in a circuit. And all of these devices are connected by this conductor or a wire or a conducting wire that completes our circuit. So since we're going to be focusing on EMF as well as potential difference, of course there are devices that are used to measure voltage across the circuit, the current of charges that flows in our circuit. And the device that is used to measure our voltage is the voltmeter, and the one used to measure our current is the ammeter. Now we are going to be talking about potential difference. Potential difference, it is said that it is the energy transferred between 2 points per coulomb charge, and its SI unit is a voltage, obviously. So in this scenario, let's say now we want to measure using our voltmeter to measure the amount of potential difference across our light bulb. Okay, across our bulb, we are just simply going to connect our voltmeter across our bulb. For energy charges transfer from positive end of our battery into our light bulb, which on our circuit is closed, meaning that current charges are flowing across our circuit, and we can measure the potential difference across our light bulb. Are we good? Okay. EMF, it is equal to the voltage of the battery, of which that is the amount or the total voltage span of a battery. You see? Okay, let us move on to a task that we can do together. Okay, it is said here, what is the potential difference of a light bulb if a charge, which is also can be denoted as Q, is 17.5 coulombs pass through and radiates 4,200, which is our energy or our work done. So according to this statement, we have our light bulb, sifuna potential difference that is across this light bulb of ours. We are given the energy and the charges. It also means that iswitch yetu in order for us to measure the voltage that is across our light bulb, our switch must be closed. Okay. And also, according to the potential difference definition of what is a potential difference, it can also be mathematically explained as potential difference is it is the energy transfer, the total energy transfer, which is can be also denoted as work between 2 points per coulomb charge. Per coulomb charge meaning our charges are at our bottom. And all we have to do right now is just plug in all the information that we have, and then we can calculate. So we will punch in our values on our calculator, and then find a final answer in 240 volts, of which this 240 volts is the amount of voltage that is across a light bulb that is connected in our circuit. Now let's go to the EMF. It is said that EMF is also equal to the total amount of energy that a battery can supply through the circuit. Okay. So if our battery supplies, let's say 40 voltage, it is worth 40 volts, our battery, meaning that it is also equal to our EMF. Potential difference is the amount of charges that flow in our circuit, and EMF is the value that is the potential